This is for Year 12 Further Maths. We're going to look at exercise 17G when we're talking about finding similar areas and volumes. Okay, so just a quick recap. For when we're scaling up lengths or scaling down lengths, depending on whether we're going from a small shape to a bigger shape or a bigger shape to a small shape, we need to multiply by something called factor K. That's a scale factor. So when we're comparing lengths, heights, radiuses, anything that's one-dimensional, you have to use a scale factor K. Now, for areas, so it could be normal area or surface area, you need to use something called K squared, so it's a scale factor squared. So if you want to scale up or scale down an area of similar shapes, you need to first multiply by K squared. For volumes, similar volumes, you need to multiply by K cubed, okay? So it's pretty straightforward once you get the concept, K squared, and K cubed, okay, for length, area, volume. So in question 1, we've got two regular hexagons, and they're similar, okay? So we're trying to find what the scale factor is for scaling up. So from here to here, what's the scale factor? Okay, what's the K value? What do I need to times 2.4 by to get to 7.2? So the formula is K is given by the new measurement divided by the old measurement. Okay, so the new measurement is 7.2. The old measurement is 2.4. If you work out on the calculator, it's 3. Okay, so we get a scale factor of 3. So that's A done. It says find the area of the small hexagon. Well, the area of the small hexagon is 15 centimeters squared. Determine the area of the larger hexagon. So to get from smaller to larger, you just need to multiply by a scale factor. So we know that this is my old shape, this is my new shape. So the new area would equal K squared multiplied by my old area. Okay, because to scale up, you need to scale up an area, you need to multiply by K squared. Okay, so K squared happens to be 3 squared because our K was 3, so K squared would be 3 squared. Times our old area 15, you should get 135 centimeters squared on your calculator. Okay, because area we have to have squared. Let's go down to the next question. Okay, so we'll apply this theory again to another question. Octagonal prisms are similar. Okay, so the height of the small prism is 2, and the height of the large prism is 3. Okay, so we'll call this my old, and this is my new. So let's get our K factor. We're trying to find the area of the larger prism. Okay, so my K value is my new divided by old. Okay, we'll talk about lengths here for K. So 3 divided by 2, or it happens to be a height in this case, and that's fine. That's a one-dimensional measurement. So K is equal to 3 over 2, and we're trying to work out the surface area of the new prism. So new area equals K squared by old area, okay, or old surface area. So K squared is 3 over 2 squared. Make sure you put a bracket in when you enter it in a calculator. Multiplied by the old area, which is 18. So let's see what we get. So on the CAS calculator, you'll go 3 on 2 squared times by 18. And you should get 40.5. Okay, so the area, the new surface area of the larger shape is 40.5. Okay, my word died, so no, it didn't, not yet, not quite. 40.5 meters squared, and that should be your final answer. So remember, when you want a similar area, you need to multiply by K squared. When you want a similar volume, you need to multiply it by k cubed. If you want a similar length or height or anything one dimensional, you minimum by k. Hopefully that helps.